Hey guys, this looks like a fun one. It says two overlapping squares. What is the shaded area? And we're given that this distance is 5. This is day 27 of our Advent calendar. For the month of December, we're going to solve 31 Katrina Ag puzzles in 31 days. And if you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. Label the side lengths of this square x and the side lengths of this square y. And then let's frame what we're trying. So this side is going to be y, and let's make this side z. So right away, we can write an equation for this area. The area is equal to y times z. This looks important. Let's put a box around it. And let's drag it down here. And next, I see a right triangle right here. Let's do the Pythagorean theorem. It'll be x squared plus 5 squared equals y squared. This 5 squared is equal to 25, and we can bring down everything else. And then next, let's subtract x squared from both sides. On the left-hand side, these will cancel each other out, so we're left with 25. And then on the right-hand side, we'll have y squared minus x squared. And this looks important. Let's put a box around it. We can clean this up, and let's move this down here. Next, this angle up here is the same degrees as this angle here. Let's prove it real quick. This will be fun. Let's call this angle A, this angle B, and this angle C. So if we look at C and B, they form this right angle of this square. So we know that C plus B equals 90. And then for the same reason, this B and this A form this right angle, so that's going to be B plus A equals 90. And then since C plus B and B plus A both equal 90, we can set them equal to each other. We end up with B plus A equals C plus B. And then from here, we can subtract B from both sides. And we end up with A is equal to C. So these two angles are equal to each other. We're done with the B, and let's change the C to an A. And that was the demonstration for why these two angles are the same. Let's clean this up. Next, let's focus on this triangle right here. It shares this angle with the square, so we know that's a right angle. And we have an X and a Y. This is pretty cool. Next, let's focus on this triangle. There's a couple things we can identify. This angle is a right angle. The hypotenuse of this triangle is the side of this square, so it's also equal to X. And then for this side, well, this piece is equal to z, and the whole thing is equal to y. So that means this part of the triangle is going to be the whole thing y minus z. And I think that's everything we can find out about this triangle. Let's focus on these two triangles, and let's rotate them like this. These are similar triangles. Any two triangles that have two corresponding angles are similar. And that's because these third angles would also have to be congruent. Since these triangles are similar, we can set up a proportion. So we can do hypotenuse over hypotenuse equals medium side over medium side. So that'd be y over x equals x over y minus z. And then from here, we can cross multiply. It'll be x times x, which is x squared, and that's going to be equal to y times y minus z. And then from here, on the right-hand side, we can distribute this y to both of these terms. Y times y is y squared, and then we're going to subtract y times z, which is yz. Now from here, we have an x squared, a y squared, and a yz. That's the same thing we have here, x squared, a y squared, and a yz. Since the yz is what we're trying to solve for, let's get it all by itself. I want it to be positive, so let's move it to this side. First, to get rid of this, we'll subtract x squared from both sides. And then to move it over here, let's add yz to both sides. This x squared and this x squared will cancel each other out. And same thing for this yz and this yz. They will cancel each other out. So we're going to be left with yz is equal to y squared minus x squared. So I'm pretty excited we're pretty much done. Let's drag this up here and copy down the yz. Yz is equal to y squared minus x squared, but 25 is also equal to y squared minus x squared. So we can plug in 25 right here. So now that we know yz, we know the area. In the place of this yz, let's plug in 25. And let's give it a label of units squared. So 25 units squared is the answer to our question. That is the area of this shaded region. How exciting. And here's tomorrow's question. It says, what's the sum of the two marked angles? We want this A and this B. What do they add up to? Looks like we're given two circles that are tangent at a point, and they're also tangent to the same line. This is going to be a fun one. How exciting.